Class 11th Chemistry, Unit 5, States of Matter, and in this video we will discuss about gaseous state and Boyle's law. First come to characteristics of gaseous state. Gases are highly compressible. Gases exert pressure equally in all directions. Gases have much lower density than the solids and liquids. The volume and the shape of gases are not fixed. These assume volume and shape of the container in which these gases are kept. Gases mix evenly and completely in all proportions without any mechanical aid. The forces of attraction between their molecules are negligible. Now you can see this representing the gaseous elements. In periodic table there are 11 elements that can exist as gases like helium, neon, argon, krypton, xenon, radon. These are the monoatomic gases, while hydrogen, nitrogen, oxygen, fluorine and chlorine, these exist as a diatomic gases. Okay. Gas laws. These laws are relationship between measurable properties of gases. Now, these properties are like pressure, volume, temperature, and amount of gas. And these are the laws. Boyle's law, this gives the pressure-volume relationship. Charles' law, temperature-volume relationship. Gay-Lussac's law, pressure-temperature relationship. Avogadro law, volume-amount relationship. Okay, and in this video we will discuss about the Boyle's law. It was given by Robert Boyle, and its statement is: at constant temperature, the pressure of a fixed amount of a gas varies inversely with its volume. We can say if temperature and amount of gas is constant, then pressure is indirectly proportional to volume. Mathematically, we can write P, this is the symbol of proportionality, that is 1 by V. According to this, we can say that is pressure is indirectly proportional to volume, or we can also say pressure is directly related to 1 by V. Okay, conditions are constant temperature and amount of gas should be constant. If we remove this proportionality constant, then K1 will come. If we rearrange this equation, we will get PV is equal to K1, and that is a constant. You have to remember this relationship. That is product of pressure and volume remains constant. At constant temperature, product of pressure and volume of a fixed amount of gas is constant. If a fixed amount of gas at constant temperature T occupying volume V1 at pressure P1 undergoes expansion, that is volume is changed. So the volume becomes V2 when volume is changed. That's why pressure becomes P2. Then according to Boyle's law, we can say P1 V1 is equal to P2 V2, and it is constant. Okay, you have to remember this relationship. If you rearrange this, P1 by P2, and this is equal to V2 by V1. And from this we can also find out the relationship between pressure and density. See, as we know, density is equal to mass by volume. Okay, and from that Boyle's law, that is P is equal to K1 1 by V. From this we can write V is equal to, that is K1 by P. Put this value of V in this, then you will get this. If amount of gas is constant, then this will give the new constant Ks. And from this relationship, that is D is equal to K dash P, we can say that at a constant temperature, pressure is directly proportional to the density of a fixed mass of the gas. Okay. Now, graphical representation of Boyle's law. Okay, actually, Boyle's law gives the relationship between pressure and volume at constant temperature. That's why plot between pressure and volume at constant temperature is known as isotherm. Okay, isotherm means constant temperature plot. Just see, this is if you plot a graph between pressure and volume, then we will get this one. Okay, these different three different temperatures it is given. If we plot a graph between pressure and 1 by V, then we will get the straight line passing through the horizon. Again, this is at different temperature T1, T2 and T3. Each line represent the isotherm. In general, we can represent this Boyle's law. If we plot a graph between P and V, we will get like this. If we plot a graph between P and 1 by V, directly proportional both are. That's why we will get this line, straight line passing through the horizon. And if we plot a graph between P, V and P, as we discussed that P product of pressure and volume remains constant, that's why we get this graph. Okay. Now see one problem 5.1. A balloon is filled with hydrogen at room temperature. It will burst if pressure exceeds 0.2 bar. If at 1 bar pressure the gas occupies 2.27 liter volume, up to what volume can the balloon be expanded? Now see the solution. According to Boyle's law, we know P1 V1 is equal to P2 V2. Now in this question, P1 is 1 bar, then V1 will be 2.27 liter. This is E1. And if P2 is equal to 0.2 bar, then we have to find out value of V2. And according to this relationship, we can say V2 is equal to P1 V1 divided by P2. Put the value. V2 is equal to 1 bar into 2.27 liter divided by 0.2 bar, and this is 11.35 liter. This is the volume at pressure 0.2 bar. Okay, and since balloon burst at 0.2 bar pressure, the volume of balloon should be less than 11.35 liter. Okay, thank you.